So yeah, that's my name, Venki. And what I'm going to talk about is I'm going to quickly talk about a project which we did um, as part of a very large financial organization. And what I'm going to try and do is I'm going to walk through what I did, what we did as a team, and hopefully there is some value um, from that. So it's a kind of lesson learned. It's a kind of project walkthrough. It can be fairly technical. It can also be fairly. Hopefully, we get something in terms of understanding how that worked and what happened and what we could have done better and so on. The first thing, just as a quick introduction, is obviously my name is Venki, Venkatesh Sellappa. Venki, I'm a my official title is Director Partner Engineering EMEA. I'm essentially a solutions engineer, and I work for a company called Hortworks. I don't know if any of you guys have heard of or know of Hortworks. Anyone here who knows? Well, there we go. So that's almost 60% in machine learning terms. I work for Hortonworks, and before that, I used to be what's called as a quant. Anybody knows what's a quant? Okay, so I'll give a quick background on what a quant itself is. A quant is a person who works in the financial side with finance organizations, largely with traders and salespeople. So if you do a lot of math and you know a little bit of computer science, you're probably going to become a quant in any large financial organization. And so I used to work for hedge funds and banks for about 14 years. I still have a soul, so please don't look at me like that. But I used to work for very large banks doing what's called as FX options trading. And so traders would be sitting there, and we would be, as a quant, you would be sitting next to the trader, and your job is essentially to come up with models, AI models with a lot of work around sort of Monte Carlo simulations, with a lot of modeling that is now coming down into what I call as retail data science. So we're all now called data scientists. I don't particularly like that term, but I think it's the term everyone uses. So we're all data scientists now. So that used to be that's my background. And what I want to do is effectively walk through how this particular project and what we could have done better. Now, the first thing around it is if you are a data scientist, and I'm talking from the perspective of someone who is doing this on a day-to-day basis. So this is not academia. A lot of people who come into the quant world, who come in and do data science on a regular basis, they all come in from the world of academia. So, someone like me comes in from a math background. There are people who are physics, and lots of physics PhDs are there. And they all come in with their own tool set, with their own toolkit. And one of the things that happens with their own toolkit is obviously what we call as a quant workbench. And a quant workbench usually has got these 3 or these 5 different types of tools, I would like to call them. So on one side of it, you've got things like sort of Python, R, and MATLAB. And Python, R, and MATLAB are what we call as discovery type tools. So whenever you're working on Python, or when you're doing some stuff with now you do a lot of work with TensorFlow and things like that, you are, in essence, most of the time, you're trying to get or trying to discover the meaning of data behind large amounts of data. And the reason why it's either Python or R, or MATLAB is a specific case, but it's either Python or R, tends to be because it's easier for discovery. So if you look at it from a 10,000 feet view, it's a lot more easier to do quick and dirty things with Python and R. Once you have actually done that, now when you try and productionize it, that's a much bigger challenge. And the productionization of models that are written in Python or R, irrespective of the underlying framework like Anaconda or taking things from any one of these other other libraries, those coming into a production system is not something that spans and seamlessly works. And at that point is where people start talking about kind of what we call as the traditional tools, which is the SAS and Java and C++. So the Quant Workbench essentially consists of these two different categories of tools. One is the Python and R world, which is effectively the discovery world, where you go and say, and especially now, people who are coming in from pure mathematical background, they would essentially work with R. People who come from the IT background tend to work with Python because it's a lot more easier. And then you get a lot of these libraries that work on top of it, and you go and say, I'll create a pipeline in this, or I'll create a pipeline using one of the big data tools, or I'll have something which is coming in from Anaconda, use NumPy, SciPy, some things like that, and I will create a model. Now, once you've done that, and then you say, I want to integrate the model and put it into a production-like scenario, that's where the traditional IT tooling comes in, which is Java, C++, and or SAS. Now, I know nothing about SAS, so I can't give you an answer, but I've seen people use it. It's apparently a really good tool. I don't know. With Java and C++, obviously, it's more on the lines of saying, how do I integrate with existing tools? And that's where Java and C++ really shine. That's one. The second thing that also happens with Java and C++ is the ability to get it to a point where it's extremely performant. Now, because I'm talking about trading systems, specifically trading systems, and we have seen that this tends to work with other systems like, systems in telco, systems in retail, systems in advertising, and, within the industry. It's the speed of execution. I don't know how many of you guys are Python programmers here, by any chance? Python programmers, kind of. So the one big thing that you end up getting with Python is obviously the GIL, which is, anyone knows what's the GIL? What am I talking about? It's the Global Interpreter Lock. So if you take Python libraries, any Python library that you have is not multi-threaded. It's always single-threaded at the end level. And the reason it's single-threaded at the end level is primarily because Python has what's called as a global interpreter lock. There is only one thread in Python that can execute at any point in time. Irrespective of the number of cores you have at the background, if you have one Python VM, there's only one thread that is executing on it. And this is just the way Python is designed. Then you are essentially going into sort of separate, you're going into C, exactly. And which is why I'm talking about C++ over there. Which is that so the reality of the situation is that you start off with trying to say, I am going to do data discovery. And like I said, because this is a project, I'll specifically talk about the kind of project we were doing. In trading systems, one of the key things that you get is you get huge amount of noise. And you have to find out what the signal is behind it. And that's easier in systems like Python or in using libraries which are written in Python because it's a lot more less formalized. It's a lot more informal. It's easier to work with. But it has this other side of the effect, which is it's never going to be as fast as what's written in a Java or a C++ language. And it's just the way that it is. It's not a good or a bad thing. It's just the way it is. There is something very similar in R as well. R is also not something which is traditionally multi-threaded or can use multi-cores. I did a talk at the Aarhus University of Mathematics in Denmark, and they are one of the big users of R, and they had lots of people coming in from RPAN and so on and so forth. And their definition of big data is essentially if you have 100 rows. That's effectively big data for them because that's literally the kind of level of performance that you get from something like R. So when I started working in this particular industry, the first thing that happened was I noticed this, which is a lot of us were doing Python and R to kind of do the discovery side of it. And then we would go into Java and C++ or SAS to go in and try and sort of make it automated or get it to a point where it can go or scale it up to a point where it can get into production. And this is a lot more harder than it looks, primarily because the same libraries do not translate 1:1. That's number one. Number two, these algorithms don't really work as it is, because if you have an algorithm that works when it's single-threaded, it's not necessarily the case that it will work the same way when it's multi-threaded. MATLAB is a specifically different case. Anyone used MATLAB here? So MATLAB is obviously one of those things which has got tons and tons of mathematical things on the back of it and does lovely graphing and all of that. There is no direct equivalent of it. Now, after having given that sort of a background, let me walk you through what we needed here. So the things that we needed from this project perspective was two things. One, the ability for people to go and do trial and error, which you obviously can't do in production because it's a bank. You can't lose money just by doing trial and error like that. The second thing is the ability to do large amounts of data ingestion. So there are two parts of these are the two things that programmers who were working on this, or quants who were working on this, needed. The ability to do trial and error, which is something that things like R and Python provide. The ability to ingest huge amounts of data. So one example that I can give you is, let's say you're trying to find out what example can I give you? Okay, let's say you're trying to find out what the price of potato is going to be 6 months from now. Does anyone know what are the things you should be looking for? So if I'm a commodity trader, which means commodity traders are effectively trying to find out prices of petroleum, oil and gas, you could be a potato commodity trader. What are the things I should be looking for? Monsoon is one. That's actually a good that's a good thing. Monsoon is one, so that's weather data. Sorry? McDonald's sales prediction is another, and that's very, very good. How the crop did. So because you're looking at future, right? So you are supposed to get there. You're not supposed to be, you don't want to know what the spot price is today. You want to know what the future is going to look like. That's where your bet is going to be. And then you create what's called as a strike price. In 6 months' time, I will guarantee, or I will buy potatoes off you for $5. And the current price is 3.5, so I'll buy it at $5. Are you willing to strike? That's the kind of, that's essentially in a 10,000 feet view. What else are we looking for?
Seasonal buying trends from last year, previous year?
Historical data, essentially, historical data. So these are some examples. One of the examples that I can give you is, and this is something that we were taught when I first started working in this area, was when Chernobyl happened, which is, I think it happened in the mid-'80s or something, in Russia in the mid-'80s. Even I'm not that old, so I wasn't working at that time. But when it happened in the mid-'80s, apparently one of the traders, the first thing he did was he struck a deal where he said the price of potato is going to fall in 6 months' time, because apparently that part of Russia used to be the one that made lots of potatoes. Now that's the kind of sort of future thinking that you have to be, the price of potato is going to rise because Chernobyl is one of the primary areas where potatoes were grown in Russia. So that's the kind of data that you have to be looking at. And this is, I was never in a commodity trading thing. I was more on the FX option side. So which means, as a recent example, when Britain came out of the UK, which is Brexit, the value of the pound against the dollar fell by 10% overnight, which means that £1 billion changed hands overnight. And the billion is just based on the amount of transactions that happen on this currency pair, which is GBP USD. So it was very profitable for someone, and it also meant that someone or some group of people lost $1 billion. Remember, in FX options trading, there are no, it's a zero-sum game. So someone has to win for someone else to lose. It's not that you're producing anything. And unfortunately, a lot of our financial system is actually based on the fact that someone has to win for someone else to lose. Nothing is actually created. It's just simply, it's a zero-sum game. It's basically, money moving from one end to the other. So that was the project. Now, all of this is fine, but there is one thing that is critical in finance, which is Excel is king, irrespective of all of the tooling that you've talked about. So we talked about tooling, which is Java, C++, Python, and R, and the issues around scaling. We talked about MATLAB, which is slightly different. Then we talked about what was the requirement, which is the requirements tend to be around things like trial and error, the ability to do trial and error without having to, without going on to someone else's problems, or without creating production scenario issues, and obviously the ability to ingest lots of data. But in spite of all of that, all of these things are fine, but on the front end, the way that most traders work and the way that most of the quants work is effectively Excel is king. And I did this sort of this study, or not a study, I did this sort of talk at Spotify. Does anyone know what Spotify is? I hope everyone does, yeah. So Spotify has got one of the largest data science community in I think in EMEA. And they've got bunches of really, really smart data scientists, and they bring in all of these guys from, as soon as they come out of academia. And the one thing that I asked them was, what do you actually use when you're trying to, when you're trying to see results of your model simulation, or you're trying to do something where you're trying to figure out how to scale this up and so on. And the first thing they said was, we use Excel. And the reason they use Excel is because Excel is one of those tools. Excuse me. Excel is one of those tools that is amenable to quick, fast changes. Anyone of you guys use things like Jupyter and Zeppelin and so on? Jupyter and Zeppelin attempt to be like Excel. They're about, I would say they're about 10 generations behind Excel, probably a little bit more. And this is someone who has been using, if you've done VBA macro programming, then you know the kind of power that Excel can wield, which you cannot have. So this is an additional thing I wanted to sort of mention. Now, these are all related to the way that you want to scale your analytics. Bear in mind that you can't scale your Excel doesn't scale. That's a problem. But 60% or more of data scientists in finance use Excel. Excel doesn't scale. So you don't have Excel where you can say, I'm going to run Excel on a cluster. That doesn't really work. You've got to say, I've got to run Excel on a desktop. That's the only way it works. But you cannot take a data scientist away from his tool and expect him to be productive. It just doesn't work. So anything that we do in terms of being able to scale the whole pipeline, from model creation to model development, to be able to look at the model and figure out how it's working in production, and then the most important thing, which is after you've done your training of data, how do you reinterpret the results and be able to create a new one? All of these things require some way of being able to scale this. Now, the project, like I said, it's a project that we worked through. Does anyone know what this is? I will. But does anyone know, just as an idea as to what this is? And this is... It's a 100,000 feet view of a particular product which needs to be assembled, and which is one of the biggest products that was sold in the financial markets from the year 2000. No, actually before that, from 1998 till about 2005, 2006. No, they're called CDOs. They're called CDOs. So CDOs are effectively collateralized debt obligations. And from a 100,000 feet view, if you come to a 10,000 feet view, what does CDO contain? CDO is essentially at the bottommost level, they contain subprime mortgages. Which is mortgages, they're not really called subprime mortgages, they are essentially mortgages, which is, mortgages is what you or I will pay on our particular, on a loan that we take from the bank, and the asset that we are paying for is the house. And it used to be one of the safest instruments. Now, if you look at mortgages, essentially the way mortgages themselves work, this, from a bank perspective, and this is kind of important to understand, from a bank perspective, the way mortgages work is that I give them money um, as an initial, and then they give me a bigger chunk of money, and then say, this is your asset, which means you're going to buy this asset. My bet is that that asset is going to inflate in value over a period of time, and instead of you paying me X, you're going to pay me X plus something, and that X plus something is going to cover the risk that you might not pay. But mortgages have traditionally been something that people will always pay, because that's the first thing that comes into as part of your budget. So it's traditionally the way banks have looked at mortgages is to say, this is one of the safest things to have, is if I give mortgage. What actually ended up happening as time went on is traders, with the help of quants who sit there and who are doing a lot of these mathematical formulas, understood that by taking a lot of these mortgages, which are safe instruments, if I can add mortgages that are not safe, which are the subprime, if I can add these two things together, I now have the ability of joining these two products together and sell it for a higher price, and therefore trading starts. So what ends up happening here is that in this particular project I was involved in, which was around 2005, 2006 timeframe. No, actually a little bit, yeah, 2005, 2006. I used to work for a bank called RBS. RBS is Royal Bank of Scotland, which had one of the largest number of deals in terms of being able to have it on the book, which is subprime mortgages. So they had one of the largest number of deals of CDOs. Now, in this particular CDO, there was one key criteria. Now, as quants, we all went and did all of the due diligence of being able to say, here is our model, here is the kind of risk you should be able to take, and if you package them together as a CDO, this is what we expect you to have as the end result of coming out of it in terms of profitability and so on. Except for one particular scenario. And the one particular scenario that we had was RBS entered into a deal with Goldman Sachs. Goldman Sachs came up and they did a deal that was so complex that our models took 7 days to be able to actually run. So it would take 7 days to run on top of the portfolio, and the portfolio kind of looks like this, which is divided into different parts, which is unrated and rated sort of lower. A and AAA is the higher rated one. Things that are below that are the lower rated ones. And so we were kind of trying to verify these. The market moved. So it took 7 days for you to actually calculate all of this that is written in C++ and Java and so on. But then what would happen is that in those 7 days, by the time you would actually price it, the market would move, which means that these underlying assets would change value again. So every time you have to price it, it would take you a week to price it, but by the time you price it and bring it out, the price is old, which means that your risk that you were taking on your books was always incorrect, always. This was the problem we faced. So what did we do? And what were the lessons that we learned on the back of it? We learned a few lessons. The first thing we learned was a lot of the stuff that we had done with Python, which was to be run on, which was single-threaded and which was running on a large system, even though with multiple cores and all of it, was still single-threaded. And as soon as we try and run it on a bigger system, which was Intel-based, we still had the same problems. The one place that we did find that it worked was with a power system, which is kind of interesting. But it was a little bit too late by the time we got into a power system, or by the time the bank decided that we should get a power system. It was a little bit too late. We did everything. We did everything and anything. We had people from, we had people who had written the original SciPy and NumPy code to come through and do it. Because a lot of the locks that we were getting was simply because of the fact that on the Intel system, it would always lock. And it still does. That's just the way that it has been written. But with a power system, we were able to scale it vertically rather than horizontally, if that makes sense. And that's one of the things that was a kind of lesson learned. That's sort of number one, but it's not the entire lesson. That's kind of number one. The second thing we had was, in terms of being able to run your models the way that we were doing it, we didn't, because we were using tooling like Python and R, we simply did, and with Excel on top of it, we simply did not have the bandwidth where we could actually go in and collate all of these things together and be in a position where we could change the model quickly with version control and all of that. That's another lesson that we learned on the back of that, was we needed to have tooling that allowed you to do this from a standpoint of the initial part of the pipeline development, rather than retraining the model and then redeploying it on a much larger system. That's something that you don't get with, again, with a power system. We were able to solve that particular problem as well, which we didn't know at that point. So there were two lessons learned. One was the lesson around the ability to scale vertically versus horizontally. Does anyone know what's the difference between vertical and horizontal scaling? You have to get multiple boxes for them, right? So that's one thing we learned, which was if we had initially started off with something like a power system, we would have been able to do that, which we didn't. It was a little bit too late for it. That was one. And so a denser system like a power system that allows you to deploy something where you can, and if you need more memory, or if you are in a, or if you need more compute power and you can add on to it, that's something we didn't have. The second thing around this was obviously the fact that if a model, as the market changes, the underlying contribution as the underlying instruments change, the market changes. For you to be able to have a model learning system that allows you to retrain the system on its own quickly is something that we did not have at that point. And that's something, again, which we learned, is the ability to have a system that allows you to train and retrain the model and have the ability to have it version controlled within the system without having to deploy it across multiple systems again. That would have been a big advantage as well. One other thing before I, and I know I'm the last one today, so one other thing which I wanted to keep in mind is, okay, this is being recorded, so I'll be slightly careful. Okay. One of the things that you have to keep in mind with horizontally scaling systems, as well as systems and tools which use things like Excel, is the fact that you don't have built-in security and monitoring. And the reason why you were using tools like that was simply because we could not, like I said, we could not scale vertically, we were scaling horizontally. Now, what security and monitoring got to do with this is that there were instances where traders had gone in and changed the numbers. And it was possible for them to do that simply because of the fact that this was horizontally scaled across multiple systems, and there was a security lapse in being able to control access to all of these multiple systems. This was something, again, which was found out much, much later on, but it was a life lesson to be learned that if you're scaling horizontally, and especially if you're scaling across in an HPC type environment where you are effectively having agents that run on other systems, you can't just decide that this is going to be as secure as the primary server. It was just something that wasn't even thought about. It was a problem that nobody thought about. But it was a problem that ended up coming in when we found out that we had all of these other agents that were running in multiple systems, and these agents went, and there was ways of people to go in and kind of change those agents to change the numbers on the back of it. And this is this then came out in a paper which was later on published and so on. But and I can give you the address of these papers and so on. But there's a very large lesson to be learned out of this. So, and I'm completely out of time, as he has just mentioned. So what I'm going to do is I want to leave you with 3 things to keep in mind. I'm more than happy for you guys to ask me specific questions on any one of this. But 3 things to keep in mind, which is, one is if you move away from academia and do this in the industry, which is what we do and which is what I did for a really long time, the kind of problems that you face are different from what you would face in a much more secure, closed environment. That's number 1. The second thing is the ability for tools to be, you will always have a difference in tools and the kind of tools that you have that you use for a small model learning environment might not be the same tool that you can use for a production environment where your model needs to work with much larger data sets, where your model needs to be in a position where it is able to be retrained and deployed very, very quickly. And if you have a horizontally scaling system, that makes it much more harder. The third thing is security and monitoring. And that's something with a large number of HPC systems in any kind of data center, you will always have that as as not really a bottleneck, but you'll really have that as something that needs to be kept in mind when you're sort of retraining and writing and doing your development on these. And this is just some lessons learned from a project that was part of the sort of biggest economy crash that we had, at least in the last 100 years. So that's all I have to say. And thank you very much. Thank you.